What's up guys? Today we will be doing Raffles Girls Primary School Prelim Examination Primary 6 2024 Paper 1 Booklet B. First we'll be looking at question number 16. Alright, it says find the value of 11 over 12 divided by 3. What we want to do first is just to write it down. Okay, and there are a few changes I want to make with this. First thing I want to do is to change my whole number into a fraction as well. So instead of 3, I want to write it as 3 over 1. Alright, what's next? I want to flip the sign. Okay, so instead of divide, I want to change it to multiplication, times. Right, but whenever I change the sign, what do I have to do? I have to flip my fraction. So instead of 3 over 1, it will be 1 over 3. And from here, what we can do is take the numerator times the numerator and denominator times denominator. So what I will get is 11 over 36. And this is my answer for question number 16. Moving on to question 17. 7 lines are drawn in the square grid. Alright, the question says, name 2 lines that are parallel to each other. What does parallel mean? Alright, when 2 lines are parallel to each other, no matter how far you extend from both ends of the lines, right, the 2 lines will never meet. Okay, that's what parallel means. How do we tell if the 2 lines are parallel? What I want to do is to test a few things. Right, first I'm gonna list down the lines that might be parallel. Alright, so we can see that we have AG and BC over here. They look like they might be parallel, but I'm gonna put it to the test. Alright, let's see. How are we gonna do that? We are going to count the number of jumps vertically and horizontally. Alright, so for AG and BC, if the horizontal jumps and the vertical jumps match, then they are parallel. Alright, so AG we have 1, 2, 3 verticals and 1, 2 horizontals. For BC we have 1, 2, 3 verticals. Okay, getting there. And only 1 vertical. Therefore, these 2 are definitely not parallel. Now let's look at DE. Okay, for DE we have 1, 2 and 1. 2 and 1. So what I can say is that all these lines are not parallel to each other because none of them match up. Using another color, I want to look at AB and GF because they look like they might be parallel too, right? Okay, so AB and GF. Let's look at AB first. We have 1 vertical and 1, 2, 3. 3 horizontal. For GF, we have 1 vertical, but how many horizontals do we have? 1, 2, 3, 4, 5. Therefore, these 2 lines, AB and GF, are not parallel as well. Okay, now looking at CD and FE. Let's look at CD. CD has 1, 2, 3. And 3 verticals and 1, 2, 3. 3 horizontals. FE has 1 and 1. Alright, but you notice that for FE and CD, their ratio are the same. 3:3, what we can do is to reduce these to 1:1. Okay, and therefore, the 2 lines that are parallel are CD and FE. And this is your answer for question number 17. Moving on to question 18. Let's read the question together. In the program guide shown, one movie leads to another without any break in between. What this means is for A Little Princess, the start time is 5:45 p.m. but the end time is 7:20 p.m. right? At the same start time for Wonder, which is 7:20 as well, with no breaks in between, and the end time of 9:15 p.m. And of course, the Secret Garden starts at 9:15 p.m. but we do not know what time it ends. Okay, so this is the information we got out of this table shown. Alright, now let's look at the question. What is the duration of the movie Wonder? So immediately I want to fix my eyes on only Wonder. What can we do? Whenever I am faced with a time question, I want to bring in my A, B, C, D. Alright, this question is definitely a time question. So A will be always make it whole. B is to break it up. C is to cancel out. And D is to draw a timeline. Looking at Wonder, we know that it starts at 7:20 p.m. and we want to find the duration of it all the way until 9:15 p.m. So 7:20, after 1 hour it would be 8:20 p.m. But you realize that the next hour, if I were to add another hour, it would already be 9:20 p.m. which is actually past the end timing. Alright, so what we want to do is to make it whole first. Right, I know that 8:20 is 40 minutes away from 9. So what I'm going to do is to break up this timing into 40 minutes first. Okay, knowing that it will be 9 p.m. From here, what we can do is just to simply say that from 9 p.m. to 9:15 p.m. is definitely 15 minutes. Are we understanding so far? Right, and what we have to do is just to plus these figures together. So we have 1 hour plus 40 minutes plus 15 minutes. It would just give me 1 hour and 55 minutes. And that is my answer for question number 18. Next question, question 19. What is the percentage discount for the toaster shown? Alright, from the picture we can see that the sale price is $56 and the usual price is $80. So first things first, what I want to do is to list out that my $80 equals to my 100%. Alright, and then now I have $56 equals to how many percent? From here, what we want to do is to find out what is the percentage for $1. How can we do that? We can take 100%, divide by $80. That would give me 1.25%. And from here, what we can do is just to multiply by 56 and multiply this by 56 as well. Okay, so if you take 1.25 and multiply that by 56, you'll get a total of 70%. Alright, so 56 is the amount that you have to pay, and that is 70% of the price. So the discount has to be what was removed, right? And that is just 100% minus 70%. And that would give me 30%. And this is my answer for question number 19. Moving on to question number 20, we're going to read the question together. The bar graph shows the number of items sold in an electrical store in a month. Alright, let's look at the bar graph together. For fans, you can see that the bar graph ends between 90 and 100. So the number of fans that were sold is 95. Alright, for ovens, it's at 30. Washing machine at 40. And refrigerators at 35. Alright, let's look at the question below. How many more fans than washing machines were sold? Alright, so fans you have a grand total of 95, and washing machines we have a grand total of 40. Alright, so what they are asking is how many more fans, right? So what I'm looking for is this amount over here. What I want to do is just take 95 minus 40. That will give me 55. And this is your answer for question number 20. Okay, moving on to question number 21. we have A and B over here. It says find the value of the following when R equals to 4. So whenever we are faced with an algebra question, we want to write down the statement first. Okay, and then what we want to do is to replace. Right, so instead of 9R, what we have is 9, 4, minus 2. When we have this, what do? We multiply, so that will be 36 minus 2, and that would just give me 34. And this is your answer for A. Moving on to B, we have 3R minus R over 9. Likewise, I'm going to replace my R's with 4. Okay, I have 3 times 4 minus 4 over 9. 3 times 4, that would give me 12 minus 4 over 9. And that would give me 11, 5 over 9. And this is your answer for question B. Moving right on to question number 22, we have part A and B. Alright, part A, round 32.047 to 1 decimal place. Whenever we are faced with a rounding up or down question, what I like to do is to write my numbers down. So I got 32.047. They are looking for us to round the number to 1 decimal place. 1 decimal place, we have to identify which number is in the 1 decimal place at the moment, which is currently 0. Right, when we have identified it, what we want to do is to look at the number that is to the right. If this number is 5 and above, we are going to round up. If this number is 4 and below, what we want to do is to round down. Okay, and 4 is clearly 4 and below, therefore we are rounding down. And our answer to this question is 32.0. Now for part B, what does it say? Write down 1 decimal between 1 over 10 and 1 over 5. First thing I want to do is to convert these into decimals, so I have a clearer picture on what decimal is in between. Alright, so 1 over 10 simply converts to 0.1. 1 over 5, what we can do is to change the denominator to a 10 first. So what I do to the bottom, which is a multiplication of 2, I do to the top as well, and I will have 2 over 10, and that would simply be 0.2. So what I'm going to do now is to draw a number line starting with 0.1 all the way to 0.2. How I can help myself from here is to actually add another digit, okay, another decimal place behind our numbers. So I have 0.10. So any number in between 0.10 all the way to 0.20 would be a valid answer, okay, and I'm just going to go with 0.15, and this is my answer for part B. Moving on to question number 23, I'm gonna jump right in. A machine started packing snacks at 8 a.m. This is sentence number 1. Right, immediately I know that this is a time question. Okay, and then whenever we are dealing with time, we deal with our A, B, C, D. A being always make it whole, B to break it up, C for cancel out, and D to draw a timeline. So now let's look at the next part of the question. It says, at a rate of 300 packets per hour. Okay, this is my sentence number 2. So now that we know the rate of production the machine has, moving on to sentence number 3, we have, after every 8 hours, it was stopped for 2 hours. Now let's look at the main question. How many packets can it pack by 11 p.m. on the same day? What I want to do now is to draw my timeline. Alright, starting at 8 a.m. ending at 11 p.m. Sentence number 3 says that after every 8 hours, it was stopped for 2 hours. So what I want to do is to find the first 8 hours first. Alright, so the first 8 hours, we know that from 8 a.m. ending 8 hours, that would give me 4 p.m. In these 8 hours, it is working, which I'm going to write at the top. Okay, but for the next 2 hours, what happens? For the next 2 hours until 6 p.m., it is taking a break, right? Okay, it's not working. So I'm going to put break over here. And then from 6 p.m. all the way to 11 p.m., we know that we have a duration of 5 hours. Okay, and this too is working. From our timeline, you can see that the working hours of this machine is 8 hours plus 5 hours. And that would just give me 13 hours. And to find the number of packets that it can pack, what we can do is just to take our 13 working hours, multiply by 300 because the rate is 300 packets per hour. And that would simply give me 3,900. And that is your answer for question number 23. Alright, moving on to question 24. Let's read the question together. A swimmer has to swim a total of 3 races in a competition. The timing for Ryan's first 2 races are shown in the table. Let's look at the table below. It says for the first race, his timing was 4.6 minutes. Alright, we want to take note that this is in minutes. For his second race, he did it in 4.1 minutes. Alright, let's look at the question. Ryan's average timing is 4.3 minutes for the 3 races. If his average timing is 4.3 minutes for all 3 races, what I can do is to find his total time for all 3 races. The total time would just be 4.3 minutes multiplied by 3. And that would give me 12.9 minutes. Now, let's look at the question. What is the timing for his third race? Okay, so now we have his first race and his second race. What I can do is just to subtract number 1 and number 2 from the total to get number 3. So I am going to take 12.9 minutes minus 4.6 minutes and minus 4.1 minutes. Okay, and that would give me a total of 4.2 minutes. And that is my answer for question number 24. Moving right on to question 25. Let's read the question together. The figure is made up of a square and 2 rectangles. Alright, so I have a square and 2 rectangles. I am going to highlight the square and, of course, the 2 rectangles. Alright, let's look at the next sentence. The area of the square is 100 cm square. Now, what is the formula for area of square? I know that the formula is just length times length. Okay, so if the length times the length equals to 100 cm square, I know that my length of the square has to be 10 cm. What I want to do is to label it down 10 cm on all sides of the square. Moving on to the question itself, it says find the shaded area of the figure. Looking at the image given, I can see that the length of the whole figure is 35 cm. What I want to do is find the base, the total base of both my triangles. So what I'm going to do is to take 35 cm minus 10 cm, and that will give me 25 cm. I know that this length over here plus this length over here, which I'm going to call A and B. Okay, A plus B equals to 25 cm. We are asked to find the area of the shaded triangles, right? First, I need to know the formula for area of triangle. That is definitely just half times base times height. Alright, we know the height of both triangles, that being 10 cm. But do we know the individual base of the triangles? No, we do not. Right, what I can do now is actually to combine the 2 triangles to form one big triangle. Okay, I'm gonna show you guys how I'm gonna do that. You realize if I were to take this triangle over here and this triangle over here, now I am going to move these 2 triangles to form one big triangle to show you guys that it is possible. Okay, I'm gonna move one over here and the other one I'm going to move like so. Alright, and you see if I were to join them together, I form one big triangle, and I know that this side is B and this side is A, and A plus B gives me a total of 25 cm. Okay, and the height remains the same, the height being 10 cm. Now, what I can do is to fill in the blanks in my formula. Alright, so I'm just gonna erase this to make some space. What I can do now is just to fill in the values of my area of triangle formula, and that would be half times base being 25 cm times the height of 10 cm, and that would give me 125 cm squared. And this is my answer for question number 25. Alright, moving on to question number 26. Let's jump right in. A pattern is formed using the letters B, C, and D. Alright, this is sentence number 1. Okay, let's go on to sentence number 2. The first 21 letters are shown. Looking at the first 21 letters below, what I notice there is that I can break it up into 3 parts, each part being a small pattern. Alright, if you notice, B, B, C, B, D, D, B is 1. And you notice that it repeats, B, B, C, B, D, D, B. That's 2. And lastly, B, B, C, B, D, D, B. That is 3. Okay, so we realize that this is a repeating pattern. Alright, it always goes in this order and then it repeats. Now, looking at the third sentence, the letter D appears 50 times in the pattern. What I want to take note is that for every small pattern, there are 2 Ds, if you notice. What I want to find out right now is how many small patterns are there in the one big pattern. If there are 50 Ds appearing in the big pattern, 2 Ds appear in one set. What about 50 Ds? Okay, how many sets does my big pattern have? Okay, this is what I am going to find out. How can I find this out? I simply take 50 divided by 2, and what I get is 25. So now I know that there are 25 sets if there are 50 Ds. Let's move on to the next sentence. What does it say? Alright, what is the smallest possible number of letter B appearing in the pattern? Okay, next thing what we need to find out is how many B's show up in one small pattern. Alright, let's count that together. We have 1, 2, 3, and 4. Knowing that there are 25 sets in this pattern, what I want to do is to find the number of B's I have in these 25 sets first. Alright, so how can I find that out? All I have to do is take 25 times the 4 B's in each small pattern, right? And that would simply give me 100. Is 100 the answer to this question? The answer is no. Why? Because of this phrase over here, smallest possible. Alright, we want to find the smallest possible number of letter B appearing in the pattern. So we cannot assume that the pattern ends nicely over here at the end of a small pattern. Alright, if there are 50 Ds, the smallest the pattern can be is when it ends over here. Alright, and if that is the case, I have to minus this 1B away from my big pattern, and that would just be 100 minus 1, and that will give me 99, and this is my answer for question number 26. Moving on to question number 27, let's read the question. There are 6 shaded shapes in the square grid. This is my sentence number 1. Alright, moving on to the next sentence, it says, shade the least number of shapes such that AB is the line of symmetry. Right, what does symmetry mean? For an image to be considered symmetric or to have symmetry, what is on one side of the line of symmetry must reflect on the other side as well. That is what it means for a figure to be symmetric. Alright, first things first, what do I want to do? I want to highlight my line of symmetry. Okay, I want to know exactly where it is before I start. Okay, next, what I want to do is to branch out perpendicularly from my line of symmetry at a 90-degree angle. So I'm just going to give you an example over here. To branch out like that, it will not be like that, or it will not be like that. Okay, it will always be at a 90-degree angle from my line of symmetry. Okay, so now that I have given you an example, I am going to start drawing my line. So from this, I'm going to draw the lines at those areas where I see a shaded part. And what I'm going to do is to draw a line branching out all the way at the opposite end. Alright, and I'm going to see if there are any differences on the red lines that are branched out. Okay, so what I can see from here is that there is definitely something missing. Okay, I have a black square over here at the beginning of my line, but over here I have nothing. Right, so what I want to do is to replicate that on both sides of the line. Okay, so if I have one over here, I'm going to put one over there. Next, I can see at the end of my red line, I have a shaded triangle, right? But I am missing one over here. So what I am going to do is to add that in as well. Alright. Okay, next what I have is what I see over here. Alright. And likewise, I'm going to do the same, branching out all the way. I have a shaded square all the way at the end right over here on my right. But on the left, you notice that there is nothing. So what I'm going to do is to shade it in. Moving on from here, gonna go down the line and see there is another shaded area over here. Likewise, I'm gonna do the same and notice that there is nothing on this side. Therefore, I gotta fill in the blanks. Alright, and lastly, the last shaded area, I noticed that, hey, both sides are exactly the same. And therefore, this is my answer for question number 27. But I want to remind you guys, please do not leave your lines inside the drawing. Okay? Be sure to erase them. Moving on to question number 28, let's jump right in. Bala glued 7 unit cubes to form the solid shown. Let's look at the question A. Draw the side view of the solid on the grid. So what I want to do for you guys, right, is to draw it at a more skewed angle that is closer to the side view. Right now, we are looking at it at a very weird angle, diagonally from the top. So what I want to do is to just draw layer by layer so that we can see clearly. Alright, so I'm just going to draw the first layer. This one over here. Alright, just the first layer. So, I will have a square, okay, where I'm going to call 1. Alright. This is my square number 1 from the side view. And then I have 2 over here. But 2 protrudes out just a little bit, if you notice. Alright, this is my 2. And definitely behind 2, there is one more. Okay, and then 3. 3 would be 2 spaces away from 1, which is over here. And it would look something like this. Alright, so looking at this, I can tell that my first layer would just be 3 blocks in a row. Alright, so the first layer will look something like this. There you go. Alright, let's look at the second layer. Second layer, I'm going to use a different color. Okay, I'm going to use blue. I am going to be drawing this layer over here. Alright, and likewise, I'm going to number them 4 and 5. Okay, so 4 would be something like that. And 5 will be right beside it. Okay, this is 4, this is 5. And you realize 5 is above 3 and 4 is above 2, right, from the side. So, 4 would be above 2 like that and 5 like that. Now, the last cube. Alright, I don't think I need to draw this one for you guys because it's just a single cube above 4. Okay, and therefore it will look something like that. And this is the answer for part A. Moving on to part B. The question says Bala painted the whole solid, including the base green. Right, this is my sentence number 1. Right, how many of the 7 cubes had exactly 4 of their faces painted green? Sentence number 2. For a cube to have exactly 4 of their faces painted green, 2 of their faces needs to be blocked by another cube. So what we want to do is to look at our figure over here and determine if 2 faces of each cube is blocked by another cube. So let's look at this cube over here right at the top. Okay, if you notice, there is actually only one face at the bottom that is being blocked by the block right underneath it. Okay, so for this cube, there is only one face being blocked. That means that there is 5 painted faces. So for the block at the top, which I'm going to call cube 1, alright, it has 5 painted faces. Alright, moving on to the next cube. Okay, we are going to look at the cube right below it. Alright, which I'm going to call cube 2. This one would be my cube 2. Alright, if I were to draw the back of it, you notice that definitely the top is covered. This side is covered as well. And lastly, the bottom is covered. For cube 2, if 3 faces are blocked, only 3 painted faces. Alright, moving on to the next cube, which is this one over here, which I'm going to call cube 3. Alright, what I'm going to do is the same. I'm going to draw the rest of the cube that we are not able to see, and to determine how many faces are being blocked. Alright, so right off the bat, I know that the bottom of this cube is blocked. And furthermore, the side of the block is being blocked. Alright, and therefore, I have 2 blocked faces. Cube 3 will have 4 painted faces. Alright, so that's one cube that has exactly 4 painted faces. Okay, let's move on to the next cube. Let's go to this one, cube 4 over here. So from here, we can see that there is only one side, which is this one over here at the back, that is being blocked by its neighboring block. So that is cube 4. Okay, it has only one face that is being blocked. That means it has 5 painted faces. Moving on to the next cube. How about the one outside over here? I'm going to call this cube 5. If you notice, cube 5, likewise with cube 4, has only one face at the back that is being blocked. And therefore, cube 5 has 5 painted faces. Now moving on to the cube that is inside over here. Alright, that we are unable to see. Okay, you realize that definitely the top of it is covered. This side of it is covered as well. The front is covered as well. This side is covered as well. So the only exposed areas is the bottom and the back side from over here. So that is my cube 6, and it has only 2 painted faces. Moving on to the last cube, the one at the back over here. Alright, likewise, what I'm going to do is to draw the cube as best as I can to represent all faces of it. Okay, so this is all the way at the back. Alright, so we know for sure that the top is covered. This side is covered. And that's all. It only has 2 covered sides. Cube 7 has 4 painted faces. Alright, so how many cubes has 4 painted faces? I see I have my cube 7 over here and my cube 3 over here. And therefore, the answer for part B is 2. Moving on to question number 29. Let's look at sentence number 1. A parallelogram ABCD is drawn on a square grid, right? So knowing that ABCD is a parallelogram, what I want to do is to label its parallel lines. Moving on to the next sentence, what I can see is that EF is one side of a triangle EFG. Alright, I have EF right over here, but what I'm missing is point G. Alright, let's look at sentence number 3. It says the sum of angle EFG and angle ADC is 180 degrees. Now, what can I do with this information? Knowing that ABCD is a parallelogram, I want to use something I call C angles. Alright, C angles just tell me that interior angles adds up to 180 degrees. Alright, and where is my C on this shape ABCD? Alright, it is right here. Knowing this, angle ADC, which is over here, when added to angle DCB, which is over here, should add up to 180 degrees. From here, I know that angle DCB should be very similar, or can I even say exactly the same as angle EFG. Why? Because angle ADC plus angle DCB equals to 180 degrees, and angle ADC plus angle EFG is also equals to 180 degrees. Alright, so looking at line DC and line EF, I immediately realize that they are the same. Right? They are the same. How do I know? If you look at my line DC, I have 1 vertical bounce and 2 horizontal bounce. Likewise with EF, I have 1 vertical bounce and 2 horizontal bounce. So from this, I know that they are exactly the same. Alright, so what can I do from here? Let's look at line BC. We have 1 horizontal bounce and 3 vertical bounce. I want to replicate that from point F of my line EF. Okay, so I'll have 3 verticals and 1 horizontal. This is where my line FG should intersect. Alright, let's move on to the next sentence. It says FG is twice as long as BC. Alright, what can I do from here? Knowing that it is twice as long, I just got to do this 2 times. Okay, so I've did it 1 time. I'm going to do it 1 more time. Alright, with 1, 2, 3 vertical bounces and 1 horizontal bounce. So this point is where G should be. So I'm going to label G right over here. Alright, let's move on to the question. It says, draw a triangle EFG on the square grid with a pencil and label it clearly. What I want to do is definitely to use a ruler to draw my straight line. Alright, I don't want to freehand it because when I freehand it, my line is not straight and that would not be good. Using a ruler, this is my triangle EFG. Now remember to erase all the workings or the markings that you have drawn to help you. And this is my answer for question number 29. Alright, moving on to the last question of booklet B. Question 30, let's jump right in. Alima had an album of local and foreign stamps in the ratio 3:4. So immediately I know that this is a ratios question. Alright, so this is my sentence number 1. What I want to do is to list down. Okay, so I got local is to foreign. right? 3 is to 4. Alright, moving on to the next sentence. It says, she gave away an equal number of local and foreign stamps. So she gave away the same number for both local and foreign. Moving on to the next sentence, sentence number 3. The total number of stamps she gave away is 40. What can we do from here? Okay, if the total number of stamps she gave away is 40, right? What I can do is just take 40 divided by 2 to know how many stamps each did she give away. So she gave away 20 local stamps and 20 foreign stamps. Alright, so she's going to be minusing 20 from both sides. Now let's move on to sentence number 4. It says, the ratio of the number of local stamps and foreign stamps left in the album became 4 is to 7. From here, I can immediately tell that this question is a constant difference question. Alright? Why? Because they are subtracting the same amount. Alright? If you realize, both sides are minus. Right? We have minus on this side, we have minus on that side. So when that is the case, the difference between local and foreign remains the same. Whenever we are faced with a constant difference question, right, we want to fix our eyes on the difference. Now, what I want to do is to add another part of the ratio, and that is the difference, of course. Now, looking at this, the difference of local and foreign is definitely just is to 1, right? But after removing it, what does it become? It becomes 3. Alright, and I noticed, right, even though the difference remains the same between the two, the units for difference are not the same. What I want to do is to multiply the top by 3, and that would give me the same units as when she has given away some of her stamps. But when I do that to one aspect of the ratio, I have to do it to the rest. Alright, so going down, I have to do the same to my local and my foreign stamps, and multiplying them by 3, what I will get is 9 is to 12. Now that the differences are matched up, what I want to do is to look at the difference in units. Alright, for local, you see we have 9. After minusing 20, it becomes a 4. Alright, so negative 20 is actually minus 5 units. And we can also check on the foreign side. Alright, we have 12. When we minus 20, it becomes 7. And likewise, it is minus 5 units as well. So what I can say is that 5 units equals to 20. Alright, and I'm going to find my Mr. Green Man, which is my 1 unit. That would be 20 divided by 5, and that would just give me 4 stamps. Alright, so 1 unit equals to 4 stamps. Now, let's look at the main question. It says, how many local stamps did she have at first? Alright, looking at the local stamps, I know that at first she had 9 units. Right, so 9 units would just be 4 multiplied by 9, and that would give me 36. And this is your answer for question number 30. Thank you.
Hi everyone, if you like this video, you can click right here for a similar video, or you can view our playlist here.